today we're doing page 6 of properties of curves. We have some graphs here. It says to write down the intervals where the graphs are increasing and decreasing. So I'm going to use a color code. So I'm just going to go through here and I'm going to color code all the parts of the graphs that are going up with green, and then I will color code the parts of the graphs going down as red. So this would be going up all the time. B has no interval going up, right? What about C? C is going up from here to here. D is going up throughout, except for maybe the very middle is momentarily a stationary point, right? Oops, that's wrong. Going up is just here. Going up is here and here. Now I'm going to highlight the parts that are going down in red. Going down. Going down. Going down. Going down. Going down. Going down. Now I'm going to write in green all the intervals that are increasing. So this would be x is greater than or equal to 3. This would be x is less than or equal to, or less than 2. Less than 2. And this would be, let's see. Well, it doesn't say strictly increasing, it just says increasing. Okay, so here we could say x is all real numbers. This would be x is between 1 and 5. This would be x is between 2 and 4, and x is between 4 and, well, it goes up to infinity, so we'll just say 4 is less than x. Now let's write down the intervals where it's decreasing. So let's see, we would put -2 less than x is less than or equal to 3. Notice how this is an open point, so we put -2 is less than. And then here it's a closed point, so we said less than or equal to 3. Next one, let's see, we'll put x is greater than 2. Let's see, for E, we will put x is less than 1, and x is greater than 5. X is less than, this is the origin, 0, 0. So if x is less than 0, or x is between 0 and 2. You might ask me, what do you do about the value 2, for example? The value for 2 is right in between the sections where it is decreasing or increasing. Which do you include it in? You could include it in either or neither. Okay, remember when we talk about increasing or decreasing, we didn't say strictly increasing or decreasing, so doesn't matter so much. Number 2, find the intervals where f of x is increasing or decreasing. So now they're giving us actual functions. So in order to find when they're increasing or decreasing, unless we know the function very well, we're going to find the derivative. So the derivative of function f is 2x in this case. 2x, if we're going to draw a sign diagram for it, we would find the 0 point. The 0 point for this derivative is x equals 0, right? So we would mark that on our sign diagram, and we would mark it with a 0, and then we would test any point to the right, like x equals 1, for example. If we plug in x equals 1 into 2x, we get a positive number, so we know that the interval to the right of 0 is positive. We can plug in any number to the left, like -1 into 2x, and we've got a negative number, so we know the entire interval to the left of x equals 0 is negative. So we know that to the left of 0, it's decreasing, and to the right of 0, it is increasing. Okay. What about the next one? Next one, same thing. It's a quadratic, but it's not obvious where it's increasing and decreasing, so we're going to find the derivative. When we find the derivative, we get a linear equation. It's a lot easier to see on the linear equation when it's equal to 0, which is the way we test to see when the sign diagram is going to transition from being positive to negative. So let's solve this equation. 4x equals negative 3, x equals negative 3/4 is the x value. That is the stationary point. It's when the derivative is 0. When is the derivative positive or negative? Let's plug in a number like 0, which is to the right, into our linear equation, and then we would just get positive 3. So to the right, it's positive. And then to the left, we could plug in a number like negative 100. If we put negative 100 into 4x plus 3, we would get a negative number, right? So in this particular case, the decreasing interval would be x is less than negative 3/4, and the increasing interval would be x is greater than negative 3/4. Okay. It should also correspond to what you know about the shape of the parabola. These two parabolas both have positive a values, so you know that they go down and then they go up. If you look at the sign diagrams say go down and then up also. Okay, next one, we got 2 over square root of x. Let's rewrite that as a exponent in the numerator before we find the derivative, shall we? So 2x to the negative 1/2 is an easier way to prepare that for taking the derivative. After we take the derivative, it's going to be 2 times negative 1/2 x to the negative 3/2. That's our derivative. If I simplify that, it'll be negative 1x to the negative 3/2. When is that equal to 0? It's kind of hard to see when that is equal to 0. I'm going to rewrite it as a square root in the denominator with x cubed. So if I rewrite it like this, it's a little bit easier to see that it's pretty hard for this thing to equal 0. In order for this thing to equal 0, the numerator should be 0, which it never is going to be. So basically it's never equal to 0, which means that this function is probably always increasing or always decreasing. If we put any kind of number in here, what's going to happen? Well, if we put a positive number, we're just going to get a negative number out, right? If we put in a positive number, we're going to get a negative number out. If we put in a negative number, then we're going to have a problem, right? Because if we put in a negative number, we're going to end up with a negative number as x cubed, and then we're going to have to take the square root of a negative number, and that's illegal. If we go back and look at the original function, the domain of the original function actually does not include negative numbers because you can't put negative numbers into the square root. So that's why we're ending up with this weird situation. So negative numbers, no. What about 0? 0 also no, because if we put 0 into the original function, we would end up with an invalid value also. It'll be an asymptote because it would be 2 divided by 0. So in this case, we're going to have an asymptote at 0. And otherwise it's going to be decreasing whenever you put in a positive number, and negative numbers are illegal. So our sign diagram basically says that there's a decreasing interval, x is greater than 0. Otherwise, there's no increasing interval. Okay. E to the x, we've actually done this one before, right? So e to the x, the derivative of e to the x is e to the x also. Remember, e to the x is a function which is like constantly increasing, right? So the sign diagram is just going to be all positive, right? It's constantly increasing. So the the interval where it's increasing is all real numbers, and it's never decreasing. What about I? Let's see. Okay, we're going to find the derivative. So it's going to be negative 2 times 3x squared plus 4. Simplified as negative 6x squared plus 4. When is the derivative equal to 0? It's equal to 0 at 6x squared equals 4. X squared equals 2/3, and x is equal to plus or minus square root of 2/3. So on our sign diagram, we would have 2 points, which are negative square root of 2/3 and positive square root of 2/3, when the derivative is going to be 0. And then we'll just check like what happens at intermediate points, like in between the two. If we put 0 into here, we're going to get a positive number out. We'll get positive 4. So we'll have an increasing function between those two critical points. If we put a big positive number like a billion in here, it's going to be negative 6 billion. So it'll be like a decreasing here. If we put a big negative number like a negative billion here, it would be a positive billion squared, because the negative would cancel out with the squared. Multiplied by negative 6, it would be a negative also. So we have decreasing below negative square root 2/3, decreasing above positive square root of 2/3, and increasing in between the two. So increasing between negative square root of 2/3 and positive square root of 2/3. Okay. What about this next one? So this next one, the derivative of 3 plus e to the negative x is just negative e to the negative x, because the derivative of 3 is just 0. The derivative of e to the negative x is e to the negative x times negative 1. So this function, negative e to the negative x, of course, is always going to be negative, because e to the negative x is an exponential, so it's always positive. It's always above 0, the asymptote. And then the negative is going to make it always negative. So that means that it's an always decreasing function. So it's always decreasing for all real numbers. Okay, and I think we're done. That's all there is, right? If you want to see what it looks like, remember e to the negative x is a decaying exponential. And all plus 3 does is raise it so that the asymptote is 3 units above the x-axis. So that makes sense that it's constantly decreasing. Okay, here's a challenge. 3x to the 4th minus blah, blah, blah. First, we're going to take the derivative. It's going to be 12x cubed minus 16 times 3x squared plus 24 times 2x. Okay, so this is our derivative, and then we're going to set it equal to 0 to see what the critical points are. Just simplifying a little bit, we'll have 48x squared plus 48x equals 0. I can factor out an x, 12x squared minus, let me factor out a 12x. 12x. So factoring out 12x, I end up with x squared minus 4x plus 4 equals 0. So now I can probably find this in factored form. Yeah, I did. Okay, so x minus 2 times x minus 2 gives us this if we FOIL, right? So I know that the 3 roots are 0, 2, and 2. So if I was to make a sign diagram, it would be have 0 and 2 on it, and between 0 and these two would be the zeros. That would be when the derivative is 0. And then in between 0 and 2, I'm going to plug in 1 into my factored function, and I would get positive times negative times negative. If I put a positive 1 here, it would be 1 minus 2, so it would be negative, right? So it would be positive, negative, negative, which would be positive. And if I put in a big number like 100 or something, then this would be positive and positive and positive, everything positive. And then if I put in a big number, a small number like negative 100 or something, I would have negative, negative, and negative, which multiplied 3 negative numbers and you would get negative. So I would have negative, positive, and positive. Okay, and so in this particular case, my decreasing interval would be x is less than 0, and my increasing interval would be x is between 0 and 2, and also x is greater than 2. So those would be the three intervals described in this what do you call it? Sign diagram. Okay, now let's do this last one. We're going to take the derivative, and it's going to be 3x squared minus 12x plus 3. We're going to set it equal to 0 to find the critical points. We're going to make our sign diagram. So in this particular case, let's see, if we factor out a 3, it makes it a little bit easier to factor. Remember, you can always use quadratic formula in these cases. And then it looks like this is a case where you're going to have to use quadratic formula. So let's do that. Let's see, negative x equals negative b, which is negative negative 4, plus or minus the square root of b squared, which is 16, minus 4 times 1 times 1, all over 2 times 1. So that would be 4 plus or minus the square root of 12 divided by 2. So in one case we have 4 plus square root of 12 divided by 2, and in the other case we have 4 minus square root of 12 divided by 2. By the way, we could simplify this a little bit, right? Square root of 12 is also equal to 2 square root of 3, so we could simplify this to 2 plus or minus square root of 3. Okay, so that might be a little bit easier to think about. By the way, square root of 3 is like 1.7. So 2 plus square root of 3, that's about 3.7. And 2 minus square root of 3, that's about 1.3. Okay, so they're both positive numbers. So if we put in a very big number into our quadratic, let's see, I'm just going to rewrite the quadratic. It's going to be like 3 times x minus 1.3 times x minus 3.7. Okay. So if I put in a really big positive number, of course, I'm just going to get a positive number times 3, so that would be positive. If I put in a really big negative number for x, I would get 3 times 2 negative numbers, which would also give me a positive number. And then finally, if I put in a number right in between 2 minus square root of 3 and 2 plus square root of 3, like 2, then I would get one negative number, and then I would get one positive number. When I subtract 3.7, I would end up with, oh, by the way, this is this isn't 1.3, this is more like 0.3, right? Okay. So if I put in a number that's in the middle, like 2 minus 3.7 is going to give me a negative 1.7, which is a negative number. And if I put 2 into this one, 2 minus 0.3, that would give me a positive number. So that would be 3 times a positive number times a negative number. So that would give me a negative number in the middle, right? So the decreasing interval would be between 2 minus square root of 3 and 2 plus square root of 3. And then the increasing intervals would be x is greater than 2 plus square root of 3 and x is less than 2 minus square root of 3. Okay, so that's it for page 6.